To solve this inequality, you'll want to go through a few steps. One step is to make sure that the inequality is set to 0, and we already have that. And the second step usually is to factor it in a polynomial inequality, and it's already factored for us. So from here we go to step 3 and find the critical points. And to do that, you set each factor equal to 0 and solve for x. Notice we drop the inequality symbol and change it to an equation. And what we're doing is we're finding the points that we're going to plot on a number line. You have -3, +4, and this divides my number line up into 3 different regions. So as our last step, we're going to pick test points in each of those regions and see which interval is going to be our answer. So for example, we have one interval from -∞ to -3, the second interval from -3 to 4, and then the last interval from 4 to infinity. And what we're going to do is see which one of these intervals will work back in the original inequality. So a test point less than -3 would be, for example, -4. You can pick any number as long as it falls within that first interval. And we're going to plug it back in to where we have it factored. So we've got -4 plus 3 squared times -4 minus 4, and we're checking to see is that less than or equal to 0. So -1 squared times -8. Well, squaring any number, any real number anyway, is going to result in a positive. So +1 times -8 is -8, and -8 is less than or equal to 0. So that's a true statement, which means this interval is going to be part of our solution. Then I go to the next interval and pick a test point between -3 and 4. 0 is a good test point. And again, we go back to where we have it factored and plug in the number 0 for x. Once again, you're just seeing, is this a true or false statement? So we have 3 squared, which is 9, times -4. And that too is less than or equal to 0. So that's true, which means our second region worked. Then we go for region number 3. Anything bigger than the number 4, I'm going to plug that in for x and see if that's a true inequality. Remember, we're plugging back up here where we've got the stars. And so I have 8 squared times 1 less than or equal to 0, whereas 64 less than or equal to 0. Now that's a false statement, so the third region isn't going to work. So in interval notation, our answer starts out here at -∞ and actually goes all the way over to the number 4. Now you could write it this way: -∞ to -3 with a bracket because we have the equals in the original problem, and then catch the second interval from -3 to 4. And you could also write it this way, again, -∞ all the way over to number 4. So either answer is a good one.